An example of expanding a logarithmic expression. Now remember, you can only expand over multiplication, division, and you can pull out powers when they're loose. So let's be a little careful with this one. I'm going to separate this as two terms, both of them with a cube root on it. And you have to remember that cube roots have an exponential of a third, 1/3 power. So I'm going to rewrite this a little bit as log base 2 of x to the 1/3 power individually, y to the 2/3 power. The 2 would be, 2 times 1/3 was 2/3, so you get y to the 2/3 power, over the mess on the bottom, which is x plus 1, all raised to the 4th power. So when I expand this, I'm just going to separate over multiplications and divisions. You cannot separate sums. So don't try to separate x plus 1. It's going to be held together by those parentheses. So the first term would be log base 2 of x to the 1/3. The multiplication becomes plus. We're going to get log base 2 of y to the 2/3. And the bottom part, since it's being divided, is going to be minus, so we're going to get minus log base 2 of the quantity x plus 1, all raised to the 4th. Alright, and the final step would be to pull the powers out front. So this 1/3 power, because of a property of logarithms, can be dropped out front. The 2/3 power can also be dropped out front, and the 4 can be dropped out front. Now one thing that cannot be dropped out front is if this x had a power on the inside, like it had a 3 or a 4 on it. We cannot pull that out front. It's stuck inside the parentheses. So our final expansion is going to be 1/3 log base 2 of x plus 2/3 log base 2 of y minus 4 times log base 2 of the quantity x plus 1. And that's it. That's all you can do. You'll notice that anything that was on the top is going to be positive, and anything that was in the bottom is going to be considered negative, which is, analogous to positive exponents being on the top and negative exponents forcing things on the bottom. And that's it. So let's do the opposite of it in the same video. We're going to contract this line of logarithms, and notice this first one isn't written as a logarithm, so we're going to have to force it to be one. Since these are ln's, 1 can only be one expression with ln. ln of some value is equal to 1. And I know that's going to be ln of e. So that'll be ln of e. The 2/3, kind of like where we were pulling them down before, here we're going to put them back where they belong, is going to go up here. So we're going to get plus ln of x minus 1 raised to the 2/3 power. Same thing with the 2. We're going to put it back where it was as a power on that expression. So we're going to get minus ln of y squared. And the same thing with this other 2 here. We're going to bring it up and put it in the z. I'm not going to worry about the minus. I'm just going to put the 2 up there. So we're going to have minus ln of z squared. Now, like the expansion, things that were on top were positive, things that go on the bottom would become negative. Plus, we're going to write this as a single logarithm. So we're going to have ln of something, and since there's positive and negatives, I know there's going to be a top and I know there's going to be a bottom. So in the top are going to go to the positive terms, which would be this ln of e and this ln of x minus 1 to the 2/3. In the bottom are going to be the 2 negative ones, y squared and z squared. So we're going to get the e up top, the x minus 1 raised to the 2/3 power, and then in the bottom we're going to get a y squared and a z squared. And you can leave it written this way if you want, or you can write it as parentheses yz all squared. It doesn't matter. It is condensed as one term. And that's it.